Okay, let's look at the concept questions from the fourth exam of fall 2012 and work through these pretty quickly. The first one, two equal mass particles are located some distance from each other. So let's draw a picture just as we try and visualize this. So we have A and B. Okay, particle A is held stationary where particle B moves towards particle A at speed v. What happens to the center mass of the two particle system? Well, they're equal mass particles, so when they're in this state it would be there. When B moves a little bit closer, okay, say after 1 second, it's moved v distance, then the center mass would move only half as far because it's always in between these two. So its location is the total distance divided by 2. So the answer is it does move. It moves towards A with speed v is wrong. It moves towards A with speed 1/2 v. The center mass is not moving away. So E is our first answer. Number 2, a car is going around a bank turn as shown. What's the direction for the centripetal acceleration? Well, definition of centripetal, center seeking. Okay, so the centripetal acceleration is always from the center mass to the center of the rotation. So it's going to be to the right. Okay, value of I cross I. You scroll down a little bit. Value of I cross I. We had definition of cross product. A cross B. See the magnitude of A, magnitude of B, sine of the angle between them. Okay, if I is 1, I is 1, but the sine of 0, they're in the same direction. Okay, so that's equal to 0. 2 centimeter diameter hollow ring and a 2 meter diameter hollow ring. So read carefully here. There's a difference. They're both hollow rings. And let's see which one reaches the bottom first. The concept we're looking for here is that only the shape matters. Only the shape. So the shape determines the mass moment of inertia. Okay, we saw several examples in our recitations where different masses or different sizes of objects, as long as they were the same shape, they would get down to the bottom at the same time. Okay, so we'll go with tie on this one. Derek is standing on a spinning stool while holding a spinning bicycle wheel. What is conserved when the plane of the wheel is turned 90 degrees? Okay, we had this demonstration in lecture when we were talking about conservation of angular momentum. Okay, there is no linear energy in this problem. The rotational energy would actually change. We could look at the numbers to do that. Linear momentum, we really didn't have that. And timeouts, Derek Dooley's gone, so we did not conserve our timeouts in football. Okay. We want to determine the mass moment of inertia of a bowling pin about the top of the bowling pin. The distance d in the parallel axis theorem is what? Alright, so d was defined as the distance from the point of rotation or point of reference, so I'll just call it rotation, to center of mass. Okay, so it's this distance right there, which is 24. Okay, Person standing at the center of a rotating circular platform starts walking towards the edge. We had a merry-go-round example here. What happens? Platform slows down, speeds up, or does it have the same rotational speed? What's changing is I. Okay, and we have conservation of angular momentum. Okay, I is actually getting larger as you walk away. So that I is getting larger. So to have the same initial angular momentum, omega prime has to get smaller. So the platform slows down. A non-rotating cylindrical disk is dropped onto an identical disk rotating at angular speed w. What is a common angular speed of the two disks? Again, we have conservation of angular momentum. Okay, so we have two objects. We have the first and the second. And so there's my first and second. And we have I1 and plus I2 because they've combined times the final omega. Okay, so they're identical disks, so I1 and I2 are the same. Okay, so I could factor that out. And again, they're the same, so it's there. Okay, and so factor it to the same. Omega 2, we'll call that the one that's non-rotating, so that was 0. Okay, so that gives me omega prime is 1/2 the initial angular speed of the first one. Okay, so that hopefully is a reasonable explanation of all our concept questions.